When you think of an American farm, you probably think of something like this: a barn, a field, a diverse group of animals. Until relatively recently, if you ate meat, it probably came from a farm that looked basically like this. And that was true around the world. But in the last few decades, the global production of meat has skyrocketed. And that's been driven by a change in how livestock is raised. In order to increase profits and raise livestock more cost-effectively, farms like this one started to consolidate and to mechanize. Take chicken farms, for example. In the 1970s, the US had around 30,000 chicken farms. By 1995, it had only about 20,000, but the amount of chicken produced in the US had tripled. This is what one of those consolidated farms looks like. Farms like this are controversial. There are ethical concerns, environmental concerns, but infectious disease experts worry about them for a different reason. A farm like this is called a concentrated animal feeding operation, or CAFO.
CAFOs are basically huge industrialized farming operations. They contain tens of thousands of animals, sometimes hundreds of thousands of animals, and they're often very crowded.
American CAFOs were efficient and profitable, and soon they became a model for farming all over the world. Today, almost all the meat we eat comes from farms like this.
Factory farms supply an estimated 90% of meat globally and around 99% of the meat we eat here in the US. So if you're eating a burger or bacon or whatever it is today, it probably came from a factory farm.
A CAFO is an environment built for one purpose: to house as many animals as possible. What worries scientists is that that also makes it an ideal environment for the pathogens that cause pandemics. A virus is really just a bit of genetic code that makes copies of itself. But that replication process isn't always perfect.
They're introducing lots of mutations as they replicate.
Martha Nelson studies viruses at the National Institutes of Health.
Most of those mutations are going to be deleterious and, won't help the virus at all.
Lots of mutations just lead to the virus dying. But occasionally, a mutation will happen that will give the virus a new ability, to be more deadly, for example, or to be able to jump from one species to another. A virus can only replicate when it's inside another organism, a host. But it can only replicate inside a host for so long. Every host eventually dies. That means even if a virus does mutate in a beneficial way, without hosts, that mutation will eventually die out. And out in the wild, or even on a small farm, new hosts can be hard to come by. But in a CAFO...
Let's say you're a pathogen, if you're in a factory farm, where you have hundreds of thousands of potential hosts. It's a bonanza.
More hosts means more chances to replicate, more chances to mutate, and a higher likelihood that a mutated virus will survive. In other words, factory farms are also factories for new viruses that we haven't seen before. And that's also helped along by the larger system that CAFOs are a part of.
There's a lot of international trade going on of live animals. We're sending these animals from city to city and from country to country. We're flying them across oceans.
Some viruses have a genetic code that's segmented into parts. And sometimes two of these viruses come into contact with each other.
Occasionally, you can have two separate viruses co-infect a single cell. When they replicate, they can just kind of swap out entire segments with the other virus. And through that, you can kind of create these chimeric, offspring that have pieces from the two parents.
Just like with mutations, this swapping and shuffling of segments between viruses is basically random. And that means sometimes the new virus is a dud.
But every now and then you hit jackpot and you come up with a radically new combination that has properties that neither of the two parents had.
In CAFOs, viruses have an opportunity to come into contact with each other all the time.
That's making it easier for a virus that exists over here on one side of the world that normally would just stay on that side of the world to travel quite quickly to another part of the world.
With viruses from different parts of the world mixing and shuffling and mutating inside animals, humans have made it very easy for a nasty virus to emerge. And actually, it's happened already.
We are continuing to closely monitor the emergency cases of the H1N1 flu virus.
In 2009, a new virus quickly spread around the world. It became known as the swine flu because of its links to pig farms in North America.
It came from the major swine production region that's right outside of Mexico City. That particular virus was able to evolve there because you have pigs coming from the United States over the border into Mexico. You have pigs from Europe. And so you have this sort of mixing bowl of pigs from all over the world that are able to share their viruses and exchange genetic components and create this really unusual pandemic variant.
By the time public health measures and a vaccine were able to get it under control, swine flu had killed hundreds of thousands of people. But viruses are just one kind of pathogen that CAFOs are really good at incubating. Because bacterial disease can spread so easily in a CAFO, farmers typically treat their livestock with antibiotics, which limits the bacteria's spread. And often, every animal gets that antibiotic, whether they're sick or not. At first, that prevents bacterial disease from running rampant through the population. But over time, just like viruses, bacteria will mutate. The antibiotic will kill most of these mutations, unless the mutation gives them the ability to resist it. And over time,
as the bacteria evolve, those that have the mutation to survive the antibiotic will become more and more dominant.
This is how we end up with antibiotic-resistant bacteria. And that becomes really dangerous if it spreads into humans.
And so then when we humans come along and try to treat the bacteria with antibiotics in our own bodies, the bacteria might not respond to those antibiotics.
One way to lower the risk of CAFO-borne pathogens would be to change the CAFO system to make the spread of pathogens harder.
We could decrease the long-distance transport of live animals. We could have smaller and less crowded farms so that pathogens don't have so much opportunity to rip through huge numbers of animals.
But making CAFOs safer for humans wouldn't address the other concerns about them, like animals' quality of life, or the lagoons of liquid manure they produce. Ending CAFOs entirely and returning to a smaller model of farming would.
It's actually entirely possible for us to have a meat production system that is better for human health as well as for the climate and for the animals themselves. We just need to abandon factory farming to get that.
We could also just eat less meat. After all, the amount of meat we eat today is a recent development. But now that we know what it's like to experience a pandemic, we should understand the risks of the animal pathogens cooking in our food systems.
It's just a matter of time before one ends up in the human population. Whether that happens next year, whether that happens in a decade, that's a crystal ball we don't know, but we do know that we are playing with probabilities. And we're continually increasing the probability as we increase the pool of viruses in these farms.